Hey class, here's the last example from class, what is it, R? Class R, yep. So we're gonna find the domain and range of this function. And when we start off, I think right away we can see that 8 can't be in the domain, right? If we look at the excluding, or if we look to exclude the denominator equal to 0, oh yeah, we don't want x equal to 8. So our domain is everything but 8. We can draw a little number line if you want. There's 8. We don't want you. We want everything else. So it means everything from negative infinity to 8 exclusive and 8 to infinity. Every number except for 8. 9, 10, 11, 12, negative 7, 7, 6, 5, 4. Also like decimals, right? Like 8.111 and 8.002 and 8.75, right? Anything that's bigger than 8, not just 9, but really any decimal that's bigger than 8, any decimal that's smaller than 8. The range, on the other hand, is a little bit trickier. So if you look at this, well, this actually simplifies. So if we take this function, we can rewrite f of x as the numerator factors as x minus 8 times x plus 3. And that x minus 8 can cancel. So it's kind of true that f of x is equal to x plus 3. And if you were just thinking about the graph of x plus 3, which has a y-intercept at 3 and an x-intercept at negative 3, you might graph it like this and be like, well, James, it looks like the graph is going to have the entire range because it goes as low as you want and it goes as high as you want. However, f of x equals x plus 3, but 8 is not in the domain. So we cannot have f of 8 in the range. So we cannot get y equal to f of 8, which would be 8 plus 3, which is 11. So this function has a range that's every value except for the value of 11. And what's really going on here is that at the point at the x value of 8, this function has a hole. If you plugged in 8, you would get 11, but you can't plug in 8, so you can't get 11. So this function, f of x equal to x squared minus 5x minus 24 over x minus 8, has this domain, right? You cannot get 8 in the domain. And has a range that includes everything except for 11. So it's negative infinity up to 11, union 11 to infinity. There's no way this function can ever equal 11. Sorry, there's no way this function can ever equal 11 because it looks like x plus 3. The only difference between this function and x plus 3 is that this function, you're not allowed to plug in 8 for x. And if you can't plug in 8 for x, that's the only way you could have gotten 11 for the function value. There's definitely a homework problem like this. So that's one of the reasons I want to do this example for you guys. But that's kind of the idea. If you have something that you can, where you can cancel a factor from the top and the bottom, you're going to have a hole at the place where x would have made those things equal to 0. So we have a hole at x equals 8, and the corresponding y value that we're missing is 8 plus 3, which is 11. So hopefully that helps. I will see you guys on Monday. Take it easy.